The next modifier that I want to talk about is the Boolean modifier, and it's a really fun one because it allows us to use objects to cut and slice up other objects. So since we need two objects, I'll take our default cube here and I'll Shift D to duplicate it over. And then on the original one, I'll go to the Modifiers tab, Add Modifiers, and choose Generate Boolean. Now, next we need to choose which object it should be Booleaned with. So I'll use the eyedropper tool and select our second cube. Now, when we overlap this object with this one, we'll get a pretty interesting cut. Though, of course, we can't see it because this object is completely solid. So let's go to the Object Properties, scroll down to Viewport Display, and set the Display As to Wire. Now we can move this object around and see the second mesh update in real time, which is pretty sweet. But this is only one type of Boolean. If we go back to the original object and back to the modifiers, we can see that there's also options for intersect, which is where they overlap, and then union, which is the combination of both. If you want a deeper dive into these types of Booleans and you're on cgcookie.com, then I'll link to Paul Kajegi's video on the Boolean modifier in his Modify course, which will give you his take on them as well. All of these have different use cases. For example, union is interesting and different than just joining the objects together. Because let's say I take these, both objects here, Shift D and move these over on the x-axis. And this one will be the original, so I'll just get rid of the Boolean modifier. And let's just join these two objects together by first selecting the wire one, selecting the solid one, and then going to Object and Join, or using the hotkey Control-J. So now they're both solid, and it looks very similar to this one, but here I'll go and apply the modifier by using the drop-down and choosing Apply, and I can get rid of the original wireframe one by deleting it, and then let's go into wireframe view. Here we can see that the cubes on the left have been joined into one solid mesh without any overlapping, whereas these two on the right are just jutting into each other. I'll hit Z and go back to solid view, and then let's look inside the mesh, just like so, and we can even tab into edit mode to see this a bit better, but these have just been cleanly joined, and there's actual geometry connecting them. We can do all sorts of stuff with this now. For example, we can take these edges that go all the way around, and I can hit Control B and bevel these out. As you can imagine, that can sometimes be very useful. Whereas with these objects over here, there's no actual geometry at the connection points between them. What the Boolean modifier is most known for, though, is subtracting one mesh from the other. So let's take another look at an example of that. I'll hide these cubes, and let's just look at this cylinder cutting out a plane. Or, well, it's not really cutting out a plane. Even though the plane does have a Boolean modifier, the cylinder is set as the object, and the type is set to difference. The reason it's not doing anything, though, is that the Boolean modifier can sometimes be kind of finicky, and it's highly dependent on the geometry. Here, the reason that it's not working is that we have edges that are exactly overlapping. If I go to top view here, and let's enable my wireframe over in the overlays panel, you can see that this part of the circle is exactly overlapping with one of these vertices on the plane. So if I take my cylinder and I move it just slightly off, then that fixes it. But if I line that up exactly, then things start to go haywire again. When we have a lot of space in between our vertices, then, it's pretty easy to fix. But if, for example, we have a really dense grid, then you can imagine that this might happen pretty often. So there's a couple things that you can do. First, you can go over to the solver options and under overlap threshold, change this value. You can set it to 0, which happens to work in this case, but if they're actually exactly overlapping, then even that wouldn't solve it. Another thing that you can do is switch the solver over from fast to exact, which, as the name implies, is going to be much slower, but also more accurate. Though this one is also not perfect. So sometimes you just have to flip between the two and see whichever one works for your geometry. For example, if I take this cylinder here and I have it punching almost through the plane but not quite, then there becomes an area where it starts to get a few errors. And that's because exact doesn't work with thin geometry quite as well. If I take this plane here and even add just a little bit of a thickness, for example, by extruding it or by adding a solidify modifier, so I'll add a solidify here and I'll drag that up above the Boolean, then you can see that solves it quite well. Even if the thickness is extremely thin, the Boolean modifier exact method can handle this no problem. But if there's no thickness, then sometimes it struggles. The exact method does have a couple different options. The first is if any of these meshes are overlapping. For example, the cubes that were in our first example, These two are self-intersecting because it's one object, but they're, the meshes are intersecting each other. That's what self-intersection is. And so if the geometry has any of that, then you'll want to turn this option on in the Boolean modifier. And the second is for if any of these objects have holes in them. But be aware that both of these options do significantly slow things down, and so it's best to have them off if possible. Here we can also solve this problem by just punching this through a little bit more, and eventually it figures it out. But if they're too close together, then it doesn't quite know what to do. Again, just because it's an infinitely thin surface. It's also worth noting that the Boolean modifier relies heavily on the normal direction of our faces. For example, if I take my cylinder here and I invert the normals, we can see that they're all facing outwards if we turn on our face orientation overlay. Everything here is blue. But if I select all of my faces here and go to Mesh, Normals, and Flip, then the Boolean modifier is going to behave a bit differently. I'll turn off face orientation, and you can see this is no longer working. So in order for the Boolean modifier to be effective, just be sure that vertices aren't overlapping, and also that your normals are correct. Here I'll go into edit mode and just hit Shift-N to recalculate the normals, and that'll fix it right away. Now, Booleaning things is very fun, and it's a pretty essential part of a hard surface modeling workflow, but because it does have some drawbacks, it's not something that you're going to necessarily want to use to solve every problem. Let's take a second and look at a slightly more complex example. Here I have a cylinder cutting out part of a sphere, and this cut looks pretty good. If I switch this over to fast, then it's not going to quite work because these edges are lining up exactly, but the exact modifier handles this no problem. But let's say this isn't the end result that I want. Well, what if I want to create a bevel that goes all the way around this newly cut out shape? Well, if I go to Add Modifier, Generate, and Bevel, then nothing's going to happen. And that's because we have vertices that are very close together. And if we go to our geometry, we can disable the clamp overlap, and we'll see that something does happen, but we get a very garbage result. This is because the mesh that we get from Booleans is often very messy. So one thing that you might have to get used to doing is, if you're working with Booleans, going in and cleaning things up manually. Now with more simple objects, you don't have to do that. For example, if you just have some cubes, like so, and let's Boolean one from the other. Let's go from Boolean, select this second one as the object, just like so, and then I'll go ahead and hide this second one. If I take this, I can go ahead and add a bevel modifier, no problem. Because this mesh is very simple, the edges that we get from it are very clean, and we just get some n-gons on the top and the sides, but that's no problem with the bevel modifier here. And this is extremely cool because we can still update this in real time. Working this way is incredibly flexible. But sometimes the mesh is just too complex, and we can't really do that. At some point, we have to apply the Boolean and clean things up ourselves. So to give an example of that, let's go ahead and select this sphere. Then I'll go to the Boolean modifier, to the drop-down arrow, and choose Apply. Then I'll hide the cylinder since we don't need it anymore. I'll tab into Edit mode, and since it's a little bit distracting at the moment, I'll go ahead and hide the bevel modifier only in Edit mode. That way I can tab into Object mode and see it, but I'm not distracted by it in Edit mode. Now to clean things up, we just need to join vertices together that are already very close together. One operation that we have already to do that is Merge by Distance. So if we select everything, we can go to Mesh, Merge, and choose By Distance. And then over in the Redo panel in the bottom left, we can slowly drag this up until the smallest vertices are joined together. And I was looking at this one in the bottom left over there, but just as long as it's not too big and starting to affect any of the other faces. So just change that to the smallest value possible, and you'll see that we've removed 10 vertices. I can look around the other parts of the mesh, and this is looking better, but we're still getting some very weird n-gons here on the sides. For example, this face over here has 1, 2, 3, 4, 5 vertices, and that's just not going to bevel very cleanly. If we go into object mode, we can see that that's indeed one of the areas that doesn't bevel super well. There's just too much overlapping. So we can also merge these manually. I'll hit 1 to go to vertex select mode, and to very quickly merge these, I'll turn on auto merge in the top right of my tool settings. I'll make sure my snapping is set to vertex, and then I can just hit G, hold Control, and snap to another vertex. I can go around the mesh looking for these, and let's just merge them to the nearest vertex on the sphere. There's nothing inherently wrong with beveling in n-gon, because we saw that on the cube as well. It's just that these vertices are still too close together, and once they get beveled, they're hitting each other at awkward angles. So I'll merge that one over there, that one over there. I'll merge these edges as well. And actually, I'll just turn on snapping here so I don't even have to hold control. Just like so, just G and then move and then hover my mouse over the one I want to snap to. And there we go. And if we wanted to make this process a little bit easier, we could have made sure that the cylinder had the same number of vertices as this part of the sphere, and we could have lined these all up exactly. But for now, this is close enough. I can also finish this off just by going to my knife tool by hitting K and making a cut from the top to the bottom on the ones that don't have an edge. I'll right-click to start a new cut and do the same thing over here on the left, and then hit Enter to confirm. When I go into object mode now, we can see that the bevel is almost fixed, but we still have some vertices up here that are way too close to each other. So I can then decide how I want to fix these. Maybe I want to merge this vertex with that one, and let's go ahead and just dissolve this one altogether, which is like deleting it, but leaving the rest of the mesh in place. So I'll hit Delete and Dissolve Vertices, and that did work out well, but it's also removed this edge, which I do want to be there. So I'll make sure that both of those vertices are selected, and then go to Vertex and Connect Vertex Path. That'll make a new edge between that face, and this should work out pretty well, though this is still pretty close, so I'll snap that one back up too. And that's good enough. Maybe I'll want to change the amount just a little bit. But now we have a bevel that wraps all the way around. Now, the odds that you're going to need to make this exact shape are not high, so the point of the tutorial isn't a follow along for this exact result. The point is that cleaning up Booleans can take a lot of manual work, especially with more complex objects. And a sphere and a cylinder aren't exactly super complex. So you can imagine how much work that is when objects are truly complicated. Another note on getting good results when Booleaning is that it works best when objects are watertight. For example, let's take two Suzannes. I'll hit Shift A and add a new monkey, and then I'll Shift D and duplicate this one over, and let's try to difference Boolean one from the other. So I'll add a modifier, generate and Boolean, and select the second monkey as the object. And now as I move this around, you can see that things start to flicker and aren't looking very good. Well, the reason for that is that the eyes of Suzanne are not connected to the rest of the body. I'll go ahead and hide that second one. Let's tab into edit mode. And you can see that if I hover my mouse over one of the eyes and hit L to select all of the mesh that's linked to whatever's under my cursor, this eye is not actually connected to anything else. Also, just to be safe, I'll turn off snapping and off auto merge, just so we don't accidentally merge anything. And you can see again that this eye is just not even connected. And remember how Booleans don't really like infinitely thin geometry? Well, according to the Boolean modifier, this is fully thin geometry because it's not closed off. It also has holes, which it tends to struggle with. So you could go through the options, and if we go and turn this guy back on, and let's go ahead and make this one a wireframe just by going to Object, Display As, and choosing Wire. That way we can actually see the cut as it's happening. Let's enable our Boolean modifier again, and we can see it kind of flicker around a whole bunch. If we go to our solver options and we turn on hole tolerant, then things are going to get a bit better. But as I said before, hole tolerant is also very expensive to use, so this is going to be a bit slower. Now, both of these are pretty low poly, so it's not really going to matter too much, but again, it does increase the calculation time quite a bit when you're working with dense geometries. So a better solution, if you can, is to actually fix the geometry itself. That way it'll work with anything, including the fast solver. So let's disable this modifier again, and let's just look at one of these at a time. I'll take the one that's in wireframe view, hit tab to go into edit mode, and what I'll do here to just really quickly fix this is select the edge loops that make up the back of the eye, just like so, and then I'll hit Control plus to grow my selection. Then I'll go ahead and just delete these vertices. Now, I'd really like to see what this looks like in solid view, so I'll go to the Object tab and display this as solid again, just for a little bit. And then to connect these two edge loops, I'll just bridge them. Now, they don't have the same number of vertices, so it's going to create a lot of triangles, but that's okay here. I'll go ahead and select both of these edge loops by Alt-Shift left-clicking on them. And then let's go to Edge and Bridge edge loops. I'll do that same thing over here on the right. Alt-left-click, Alt-Shift left-click, Edge and Bridge edge loops. And now we have one solid mesh. If I hover my mouse over the eye and hit L to select everything that's linked, then it selects the entire thing. So I'll go to Object Mode here, and then I'll turn on our second Suzanne and set this one to Wire again over in the Viewport display. And since I don't want to do that same thing over here, I'll just copy the mesh data from this object to this one. I think touched on just briefly in the Blender Basics, but we didn't talk about it extensively. But if I go to my Object Data tab, which is object data being the vertices, edges, and faces that make up the model, we can actually switch this object over to whatever data is in this object. So, for example, even if I have a cube here, and let's call this data cube data, I can take our Suzanne here and set that to cube data, and it'll be the exact same object, it'll have all the same modifiers, but it'll be sharing the mesh data of our cube, so it becomes an instance. This is pretty cool, but we just want to do that with Suzanne. So I'll go back to this object, go to the Object Data dropdown, type in Suzanne, and there we go. Now it has the eyes that are connected to the rest of the face. Then I'll go back to my modifiers here and enable the Boolean modifier, and now this works perfectly. It's extremely stable, it works really well, and yeah, if we're using the exact solver, we have to make sure things aren't exactly overlapping, but that's pretty easy to do when there's not a ton of geometry. You can see every once in a while it'll flicker when it gets to exactly overlapping, but for the most part, it works pretty well. And if we do get into one of those situations, then of course we can always switch over to the exact solver and get a better result. So we'll be using the Boolean modifier a couple times in this course, but really only in very basic ways. Just remember that if you ever have problems with the Boolean modifier, try switching the solver from fast to exact, try these different solver options, but more importantly, examine and fix your mesh. Merge vertices that are too close to each other, make sure the normals are facing the right direction, and bridge together any disconnected geometry. When you do that, then you'll find that Booleans in Blender are a really helpful and reliable tool.